All right, so here we are, 20 through 31. We have some new directions. 3 distinct letters are to be chosen from the set. So we're going to pick 3 letters from this set, okay? It says, determine the number of ways to obtain a subset that includes each of the following. The letter B, okay? So again, all of our subsets that we're doing in this particular problem have 3 letters. So 3 distinct letters, that's important. This particular question says B is one of them, okay? Now remember, for a subset, the order does not matter. And we're not reusing elements, like you can't have B, 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 right? It has to be all different elements because it's a subset, all right? Now, it says 3 distinct letters, right? Distinct is we're not reusing. That's what I should say. That's how I know it's subsets. It didn't say anything about subsets. I know it's subsets because it said 3 distinct letters. All right, now B is already one of them. We've already got B. That means we're picking 2 letters, right? How many do we have to pick from? Remember, order doesn't matter, so I need a combination. If B is off the list, then I have A, C, D, E, F, and G. That's 1, 2, 3, 4, 5, 6 to choose from. I'm doing 6. I'm choosing 2 because B has been already picked for us. So when I do that calculation, that's 6 factorial. Remember, for a combination, you also have to divide by the number that you selected. And no matter if it's a permutation or a combination, you have to do 6 minus 2. Or the number you have to choose from minus the number you're choosing. So this is 6 factorial over 2 factorial times 4 factorial. Remember, what I do is I write the top one down to match the bottom one, but I don't go that far, so 6 times 5. The 4 factorials cancel, divided by 2 factorial, which is 2 times 1. 2 goes into 6 3 times. 3 times 5 is 15 over 1, which is 15 ways that we could do this. Okay, so here we go again. 3 distinct letters are to be chosen. It does say subset. If you heard me in the last one, I said it didn't say subset, but it does. That means order doesn't matter. Also means we're not reusing any of the values. That subset tells us a lot. If we're using both A and E already, so A is part of it, E is part of it, we're only missing the one to go with it, right? So that means we need a combination. Now, A is out, E is out. Because for a subset, I can't reuse them. That means I have 1, 2, 3, 4, 5 numbers to choose from. Letters, I mean, B, C, D, F, and G. And I'm only trying to pick one of them. And so I can do 5 factorial divided by 1 factorial. Also divided by 5 minus 1 factorial, which is 5 factorial over 1 factorial times 4 factorial. I write the top one down to just above the bottom one. So that's going to be 5. If I put the 4 factorial, we'll see it cancels with this 4 factorial, and the 1 factorial is there, which is just 1, and 5 factorial divided by 1 factorial is just 5. There are 5 possibilities for this. And here's a fun one, either A or E, but not both. Now, or, you know what that means? It means we need to add. So, the first set can have A in it, okay, A in it, or the next set can have E in it, but not both, okay? So when we're trying to find 3 distinct letters, and A is one of them, we know we're choosing 2, because we've already picked A, right? And we're choosing 2 other letters to go with A. Order doesn't matter, because it said we're dealing with subsets. Now, how many do I have to choose from? Well, I can't include A, but you know what? I can't include E either, because it says A or E, but not both. So I only have 1, 2, 3, 4, 5, either B, C, D, F, or G to choose from. So that's 5 letters to choose from. And so that's going to give me 5 factorial divided by 2 factorial times 5 minus 2 factorial, which is 5 factorial over 2 factorial times 3 factorial, which is 5 times 4 on top, because I'm going to cancel the 3 factorials divided by 2 times 1 in the denominator. That's just that part. Now in green, I'm going to work on E, but not A. So I now have a combination. I've already got an E, so I'm only choosing 2 more letters to go with it. So I'm choosing 2. How many do I have to choose from? A is already included, so it's out. E is not allowed to be with A, because it said not both, so it's out. So once again, I'm just doing 5, choose 2. Now we could recalculate it, or you could just see that Over here, when I calculated 5 times 4 is 20 divided by 2 is 10 possibilities. Then in green, the second time I did it is also going to give me 10 possibilities. And since this is an OR problem, we know 10 plus 10 is 20 possibilities of subsets that have A or E, but not both. Now for 31, in the last of this group of questions, more consonants than vowels. Okay, so how could we do this? What does that mean, more consonants than vowels? First of all, we're still picking 3 letters, right? 3 distinct letters. Okay, so, you know, A, B, D, or E, F, G, 3 distinct letters. It's a subset, so order doesn't matter. But how could we do more consonants than vowels? Think about all the possibilities, not of the letters, but more consonants. Now, what are our consonants in the group? You have a B, a C, a D, an F, and a G. Maybe I should highlight those. Those are consonants. B, C, D, F, and G. And then the vowels, there's only 2 of those, A and E. So if I want more consonants than vowels, one way I could do that, I guess if they were all consonants, that would work, right? That's definitely more consonants than vowels. Or, notice the or is important because these things can't happen at the same time. You could have 2 consonants and 1 vowel. I can't write. How about 2 consonants? And I'm just going to abbreviate. And by the way, this was 3 consonants and 0 vowels. I could write that under there. 3 consonants, 0 vowels. Or I could have 2 consonants and 1 vowel. But I couldn't have 1 consonant and 2 vowels, right? Because that doesn't meet the condition of more consonants than vowels. So yes, this is the only 2 ways I could do this. 3 consonants, 0 vowels, and then 2 consonants and 1 vowel. Now the OR means what? Add. We're going to add these 2 possibilities together. Now how could I select all consonants? Well, it's a combination because we're dealing with a subset. How many consonants do I have? I have 1, 2, 3, 4, 5 consonants. Right? And we're picking 3 of them. So that's 5, choose 3. We'll calculate that in a minute. What about 2 consonants and 1 vowel? So, these go together. This is an AND statement right here. How do I pick 2 consonants and 1 vowel? So to pick the 2 consonants, I still have 5 to choose from, but I'm picking 2 of them. Okay? Times the 1 vowel. Now, another combination, I have 2, and I'm picking 1. And I'm going to multiply those together. Does that make sense? Okay, the reason there's a multiply here, because you're doing this and this. It's 2 consonants and 1 vowel. But there's an OR here, so we're adding. So when I do this calculation, this is 5 factorial over 3 factorial. Divided by 5 minus 3 factorial. It's just going to give me 5 factorial over 3 factorial times 2 factorial, which is actually 5 times 4. The 3 factorials cancel over 2 times 1. 5 times 4 is 20 divided by 2 is 10. That's 10. That's not the first time we've done this in this assignment. And then plus, okay, we're going to do this calculation. So 5 choose 2, that's 5 factorial over 2 factorial times 5 minus 2 factorial. That's going to be 5 factorial over 2 factorial times 3 factorial. Hey, that's familiar. So that's 5 times 4 on the top. The 3 factorials cancel. 2 times 1 on the bottom. I also get 10. But I have to multiply that by 2 choose 1. So that's 2 factorial over 1 factorial times 2 minus 1 factorial. That's just going to give me 2, y'all. Because that's 2 minus 1 is 1 factorial. 1 factorial is 1. 2 factorial is 2. 2 divided by 1 is just 2. So when I add this together, I have 10 plus 20, which is 30 possibilities when I add those 2 different options together. Now here we're arranging letters. Find the number of distinguishable arrangements of letters of the word Pippin. Okay. Now when you're arranging letters, remember that's a factorial. You could call that a permutation. And how many letters do we have? We have 1, 2, 3, 4, 5, 6. So that's 6 factorial, choose 6. We're just arranging all 6 of them. And you could just, that calculation is just 6 factorial. The problem is there's duplicates. And whenever you have duplicate letters, remember you have to divide by how many letters you have. So P's, there are 3 of them, so that's going to be divided by 3 factorial. I's, there are 2 of them, so that's also divided by 2 factorial. So you have 6 factorial divided by 3 factorial times 2 factorial. And I'm going to take the top one down to the biggest one in the bottom and cancel the 3 factorial, so it's 6 times 5 times 4. Again, the 3 factorials will cancel, divided by 2 times 1. You could say this 2 goes in this 4 2 times. If you want to, 6 times 5 is 30, times 2 is 60. So there are 60 possibilities of arranging the letters in Pippin where it's distinguishable, because you can't tell one I from the other I or one P from the other P. So that's why we have to divide by the 3 factorial and the 2 factorial. Again, 3 represents the P's, because there are 3 P's. And then the 2 represents the I's, because there are 2 I's. Alright, a professor teaches a class of 60 students and another class of 40 students. It says 5% of the students in each class are to receive a grade of A. How many different ways can the A grades be distributed? Oh, wow. So 5% of his 60 student class gets A's, and 5% of his 40 student class gets A's. We need to know how many that is, first of all. Okay, we can't even arrange anything until we know how many students that is. So 5%, I'm going to take the 60 in the class and multiply it by 5%. Well, y'all, to change 5% to a decimal, we need to do that to multiply. That's 0.05. Remember, change a percent to a decimal, you move the decimal 2 places to the left. The decimal is right here, if there's no decimal at all. Now, 60 times 0.05 gives me 3 students in the 60 class. I also have to calculate 40 times 5%, which is the same as 40 times 0.05, and 40 times 0.05 gives me 2 students in that class that are going to receive A's. Not a lot of A's, right? Aren't you glad I don't do it this way? What if everybody in the class had, like, wonderful grades, then only the top 5% would actually make A's? Goodness, that would be rough. Okay, now, here we go. To pick our A students in the 60 size class, we're going to have, is that a permutation or a combination, or do we get to reuse students? Well, no. If Derek gets an A and he's in the 60 class, he's not going to be getting an A again and count again. So we don't reuse, which means we can use a permutation or a combination. But the order of these A's are in doesn't matter either. It's not a separate group of 3 people if we rearrange the order of these 3 people. So this is a combination situation. So we're going to have a combination of, as a matter of fact, I meant to make this blue. So we're going to have a combination of 60 choose 3 times, because we also have to figure out these 2 A's in the other class. And this is the multiplication principle, because we're arranging these every way we possibly can. That's what the question is asking. We're arranging. So this is going to be a combination again, because the order these 2 A's are in doesn't matter. Okay, so this is going to be 40 choose 2. So we need to figure out these calculations. We don't have any duplicate situations because these classes are separate. We don't have any people that are in both classes to worry about subtracting them out, thank goodness. So we just need to calculate a combination of 60 choose 3. That would be 60 factorial divided by 3 factorial times 60 minus 3, which is 57 factorial. Now I'm going to write the top one down to match the bottom one. So it's 60 times 59 times 58. I'm not going to write the 57 because that cancels. Divided by 3 times 2 times 1. Times, here I have 40 choose 2. So that's going to be 40 factorial divided by 2 factorial. And then 40 minus 2 is 38 factorial. I'm going to write the top one down to match the bottom one. So 40 times 39 I don't write the 38 factorial because those cancel, divided by 2 times 1 for the 2 factorial. And then I just plug all this in my calculator, although I will calculate 60 times 59 times 58 divided by 3 times 2 times 1 for you first. So again, 60 times 59 times 58, all that divided by 3 times 2 times 1 is 6. I get 34,220. That's big. Times, in green, I'm going to calculate 40 times 39. And then divide that by 2 times 1, which is 2. And I've got 780. Now when I multiply that together, so 780 times 34,220, whew, I got a big number, y'all. So 26691600. If I put my commas in there, 26,691,600 possibilities for dishing out these A's. Okay, for our last problem, we have a transit bus. It can travel in only 2 directions, north and east. That's it. Okay. From its starting point on the map shown, determine how many paths exist to reach the garage. So let's talk about our paths. Now, go ahead and tell you can start every possibility, but it's going to take a while to come up with every possibility, and I think you might get overwhelmed. So we're going to have to find an easier way to do this. When I first looked at this, we're supposed to start here. If I start here, and let's just say one of the paths, I can go all the way up and all the way over. That's one of our many paths that we can take. I'm going to change colors on you, and I'm just randomly doing some examples. Or we could go over, up, over, up, over, up, over, and then up. Right? That's another possibility. Just to make a point of this, let's find a third possibility. How about I could go all the way over this way and then go straight up that way. And as you can see, there's just tons of possibilities. But now, there's something I want you to think about. What's common for all of these possibilities? Is there something that you can see that's common for all of them? Let's take a look. Like with my blue one that I did first, notice we went up 1, 2, 3, 4, 5. We went north 5. So 5 steps north. And then we did 1, 2, 3, 4 steps east. I say steps. Drives from one block to another if you want to look at it that way. In purple, let's see what we had going on there. So purple, I went east, and then north, and then east, and then north, and then east, and then north, and then east, and then north, north. So how many norths did I do? 1, 2, 3, 4, 5 in the north direction. And then east, I went 1, 2, 3, 4 in the east direction. All right, let's check out the green. Okay. When I did the green, notice I went east first. So I went 1, 2, 3, 4 in the east direction. I'm going to write that second down here with some space. How many in the north direction? 1, 2, 3, 4, 5. 5 in the north direction. Now, we could do more of these if you wanted to see more of what this feels like. Like, we could go randomly up and then over and then up and then over and then up. Just one more time, just to make this feel a little bit better. How many norths did I do? Probably 5. Look at the consistency, but let's check. So that one that looks really dark blue is my combination of purple and aqua right here is blue. So that's 1 in the north, 2, 3, 4, and then one over here is 5 in the north. Yep, 5 north. And then east, so that's horizontal, 1, 2, 3, 4 east. So it looks consistent that no matter what, we do 9 blocks, and then 5 are north and 4 are east. Every time, y'all, every time. So, again, we have 9 blocks, and when you break it down, 5 of them go north, and 4 of them go east. Now, the order to get there, does that matter? Well, kind of. But those are separate situations. They don't build on each other. Like if you rearrange the order that you put them in, you actually wouldn't get there. So I would say order does not matter in this situation. You might want to think about that further so you can wrap your head around it. But I would contend order does not matter when you do this, because if you go east, east, east right here in those decisions, it wouldn't matter if those were rearranged. East, east, east is still, you see what I mean? Like you call it north and then east, and then north, 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 east, east, east. That's your situation right there. And if you rearrange that order, would that be the same thing? Maybe I should describe the order this way. I think this will help you and me both. Okay, so you've got 9 decisions to make, right? You have the first decision, the second decision, the third, the fourth, the fifth, the sixth, the seventh, the eighth, and the 9th decision. So your first decision, you could go north or south. North or east. And so, or you could go, so your first decision, you could decide it could be north, and then the second decision might be east, and the third decision might be east, and then the fourth block might be north, and then the fifth might be east, and the sixth might be east, and then the 7th, 8th, and 9th might be north. Does that make sense? Now, if we do this as a combination, I talked about order doesn't matter. If for instance, you got that your second path, the fourth or block, the fifth, and the 9th block were your east blocks, would you get there? So the second, the fourth, the fifth, and the 9th are all east. Well, let's see. So that means the first was not chosen, so that means you go north. But the second was chosen to go east, that means you go east to the second pick. The fourth was east, so that means the third was north, but the fourth was east. The fifth was east, but the sixth was not picked, so 6 is north, 7 is north, 8 is north, and look at there, 9 is east, and you got there. So if I rearranged this order and said that 4, 5, 2, and 9 selections were all east, that's going to give me the same path. That's the best way to describe to me that order doesn't matter. We can use a combination, and we can do a combination of either picking 4 east from 9 options or 5 north from 9 options. You'll actually get the same result. So let me show you. If we select east, we're going to pick 4 different blocks to go east. And we just want to know, of the 9 blocks, I need 4 of them to go in the easterly direction. So that's going to be a combination of 9 choose 4. If I calculate that, that's 9 factorial over 4 factorial, and then 9 minus 4 factorial, which will give me 9 factorial over 4 factorial times 5 factorial. Then you know what we should do, right? 9 times 8 times 7 times 6. I don't write 5 factorial because it's going to cancel. Divided by 4 times 3 times 2 times 1. Let's see what we get there. So 9 times 8 times 7 times 6. And that gives me 3,024 divided by parentheses 4 times 3 times 2 times 1. Close out the parentheses. And I've got 126 different ways I could pick east. Now, why am I not picking the north? Because if you do a combination of 9, choose 5 for north, we're not doing both, right? We're just picking, or it wouldn't be 9 choose 5. Now it would be 5 choose 5. There's only one way to do that. Or you could select, like we said, or you could select 5 going north, and that would be a combination of 9 choose 5 instead. And that calculation is 9 factorial over 5 factorial times 9 minus 5 factorial, which is 9 factorial over 5 factorial times 4 factorial. Look, compare this and this. Notice they're exactly the same. Just the order the denominator is written in is switched around. Calculation-wise, it's still 126. And if you thought about it this way, you would pick 5 different blocks. Maybe block 1, block 2, block 5, block 8, block 9. I don't know if that was 5, but just pretend like it was 5. Then all the others would be in an easterly direction, and you will still get there. But it's 126 paths, no matter which way you go about it. You could, again, take it a step further and say, okay, I've got 9 choose 5, that's north, but don't I still have to multiply that by times? We've already picked 5, so then I have 4 remaining. That would be a combination of 4 choose 4. Yes, you could do that, but a combination of 4 choose 4 is 1. So that gives us 126 times 1, which is still 126. I really hope I didn't confuse you worse on that one. This one it takes a minute to take in and see what in the world we're doing, but after you do it, you could redo it if you had to, right? All right, that wraps up the review questions for our Test 3, which covers counting problems. I hope you have a great day.